Hello friends, namaste to everyone. We are going to study about linked list today, and I'm just going to start from the scratch. So please do watch from very beginning, because I'm going to cover each and every aspect that's under my eye. So let's get started. I'm going to start the PPT, and then in the second video I'm just going to perform how to do programming over linked list in C language. Fine. So let's start. Let's have an introduction regarding the same. Linked list introduction. So what is linked list? It's a quite simple thing. Unlike arrays, linked list is a linear data structure. Um, in linked list, the elements are not stored in a contiguous location, that is in the linear format. The elements are stored using pointers. Fine. And I mean to say in that context is the elements are linked using pointers. Fine. So why always we use like linked list in our programming language? It's because array can be used to store linear data structure, as you can see, and also we know that arrays are always in the linear format, but arrays have the following limitations, which I'm going to show it to you in just a few seconds. The first is the size of array is fixed. As we all know, the size of the array can be fixed in the compile time itself, but cannot be extended from there itself. So we must know the upper limit of the numbers and elements in advance. Say for example, if you have 1000 records to be inserted, and you have defined the entire array of 1000, it's always good to do that. But what if in the near future or coming future you want to store 1200 records or 1100 records? In short, if you want to increase the number of records, you have to programmatically perform each and everything. You have to compile it and then run it, and then you have to always and always, as and when the number of record gets increase, you have to always perform good number of operations over there in the compile time. Fine. So generally allocation of memory is equal to the upper limit irrespective of the usage. Fine. So the second limitation of the thing is that inserting a new element in an array of element is expensive, because room has to be created for the new element, and to create a room, existing elements have to be shifted. And this thing I'm just wanted to tell you one more thing, that say for example there are 500 number of records, and you have to store 501th number of record, that's 501th number of record you want to insert at that primary location. Then you have to shift the entire thing downside, that is from 501 you have to clear that room and shift it downside, so that you can insert at 501 location. So this is a problem that is available in array itself. Fine. For example, I would like to say, for example, in a system we maintain a sorted list of ID in an array. I'm just going to define var as an array. So if var array has 1, 4, 8, 12 and 18 to be as a data, fine, then what we have to do is, if say for example I want to insert 9 at particular location in a sorted order, so what I have to do is I have to shift this 12, just a second, I have to shift this 12 to somewhere downside, so that I can insert 9 over here. So this operation will be crazy in a moment, because what the problem will be, I have to clear this room, make some space, I have to shift this thing over here, and I have to create one more room for this thing, and I have to create shift this thing over here. So shifting process first I have to complete, and then I have got this place bulky and small in number, so I can insert 9 over here. Fine. So what the problem will be, deletion is expensive also. In the second most thing, if I want to delete any of the element in an array, it will be very much expensive in that context also. So we will be looking all these things. Okay, so what are the advantages of linked list over arrays? So it's first is, there are only two advantages, I'm going to cover it. in this video, that is dynamic size. If you want to increase the size of a linked list, you can increase it. Say for example, if you have 1000 records in your bookshelf that you want to insert it in the computer, you can do it. And in a near time, if someone comes up with some other data also, you can once again increase it, because the entire size of a linked list is a dynamic one. The another one is that if you want to insert or delete any of the element in between, it is very easy, because you just have to remove the links in it, and you do not have to shift each and every elements from the linked list. Fine. So these are the two basic and most required advantages. And also, what are the drawbacks? Let's cover that also. One of the drawback is random access is not allowed. That is, in between, if you want to access 15th record or 20th record, you have to scroll the entire element, just like an array. Also, we have to access the element sequentially starting from the first node, so we cannot do binary search with linked list. As you can see, the second most is extra memory space for pointer is required with each element of the list. In array, the entire thing was in a contiguous manner, and it was stored in a contiguous manner, so it was not problem in that context. But in linked list, you can see that extra memory for pointer has to be defined. Fine. So this is one of the drawback. What is this representation in C? It's quite easy. Let's see. A linked list is represented by pointer to the first node of the linked list. The first node is called as a head. Fine. We will see what is head and everything in a quite easy way. If the linked list is empty, then the value of head is always null. Fine. So in the second thing, each node in a list consists of at least two parts. This has to be made very much sure for all these things, that each node in a list consists of two parts. Fine. One is data, and the another one is pointer to the next node. Fine. So if you are creating a node, this node will either point to null, or it will be pointing to some another node. So this is one of the key aspect of getting connected the entire linked list. Fine. So in C, we can represent node using structures. Below is an example that we are going to show it, see it in a quite few seconds. Fine. So in Java, the linked list can be represented as a class and a node as a separate class. The linked list contains a reference of a node class type. Fine. So in Java, its class is already there. That is, the class name is linked list, and each and every node is represented by another class. So we are not going to cover about Java, so I'm going to concentrate on C. I just wrote it just for general knowledge. Fine. So let's see a simple sample node. It's very easy. Fine. So you have to write struct node, and then after as we can see over here, struct node, and inside that node I have defined one data. This data is the data which we want to store it, and the another one is struct node star next. This is a pointer of struct node. Whatever I have written over here, this is my data type. This is my actually user defined data type. You can see it over here. So this user defined data type, I have just typed it over here, and then I am just creating the pointer of this user defined data type. So the general anatomy of linked list is in this sequence. Fine. So a sequence of nodes, say for example this is data and this is pointer, so I'm just creating 4 nodes over here. You can see it in a great way that 4 nodes are being created. We will see it in a programming style also, how we are going to create this thing. Fine. So each node contains a value, because we have defined data over here. You can see this is a data and it might contain a value, so each node contains a value. Fine. That is 1. I am just putting 1, 2, 3 and 4 as a value, and a link to a pointer or reference to some other node. Fine, so this is the pointer, fine, which I'm going to point it to the another node, and this is the second pointer which I'm going to point to this node, and this is the third pointer which I'm going to point to this node, and this is an empty pointer, so I'm just going to put it to the null. Fine, so as you can see it over here, so it's just pointed it. The last node, it contains always null link, but if you be sure that the last node should contain a null link, otherwise in a C language it will go to an infinite zone and might produce a garbage value. Fine, so the list may contain or may or may not have a header. So in this context we do not have any header, but you can, if you wish, you can point say or describe it as a header. Say for example, this list has a header. If you want to define this first node as a header, you can define it, but it is not necessary to define, or it is not compulsion that you define this node as a head. So I'm just going to point this as a node, which is this is a pointer which is termed as a head, and it's pointing to the first location. Fine, so thank you for watching my video. This is just the beginning. Do subscribe to my video, because I'm just going to post a lot of videos on how to do work on linked list, doubly linked list, singly linked list, and a lot to come. We are going to have a lot of fun over programming styles also. Do also question me on the comments if you wish. If you find any problems or anything, you can comment on the same. Fine. One more thing I'm just going to share with you all guys is that I'm just going to share some videos with you people, so please do watch those videos, because it will be quite more interesting. Okay, so if you want the PPT, entire PPT which I have just shown it over here, you can download it from the Google source code. I have just made it open for all of you people. I'm just going to paste the entire link in description. Please do watch those PPTs, and also you can share this PPT with all your colleagues, and also you can share this video with your all of your colleagues. Please do subscribe this video. I'm just working really hard for you people. Thank you all. Thank you for watching. And also I'm just going to sorry, I'm just going to post this entire source code for you people on the web itself, so that you can also practice from the web itself, no matter if you haven't installed source C language in your PC, but you might be able to compile it from your end if you have an internet. Thank you all. Thank you for watching. Goodbye. Sayonara. Adieu.